All right. So for problem number 5, we have block 1 and block 2. It's an ideal spring. Now, ideal is almost like friction, so the springs are never ideal. I have a spring up here. If I push on it really hard for a very long time, it will change its shape permanently. So when they say ideal spring, there's other things that go on. There's heat, there's thermal issues, friction, all that stuff. But really, ideal means we're just using Hooke's law. I'll explain Hooke's law. We're not quite there to Hooke's law, but we're talking about force. Ideal spring means whatever force I put against the spring, it's going to push back. That's what ideal means, okay? So it says attached to block 2 is shown. At time 1, block 1 reaches the spring, starts to compress, and as block 2 starts to slide to the right. Later at time 2, block 1 loses contact with the spring. Both blocks slide with negligible force, which means we totally ignore friction. Taking rightward as positive, that means that going to the left is negative. Which pair of graphs could represent block 2 and the center of the mass of acceleration of a 2-block system? So it looks like I need to copy the choices, right? So this one, I'm just going to put the answer, and then I'll explain why it's the answer. Because the other day I went through all the options, and you guys yelled at me. I said, well, we could do it this way. And you're like, why didn't you? Well, you said. I was very aggressive that day. All right. So it's this one. All right. What are we measuring? So this is the correct answer, A. All right. And we're measuring the acceleration of the block. So block 2, for the most part, is sitting still, right? So what happens is block 2 is sitting still. Let's reread this so it makes a little more sense. Block 1 slides right. Right? So block 2 is just sitting there minding its own business, living its best life, just outside. Block 1 comes along and slides into the spring. Now the spring, prior to that, block 2 is not moving at all. So here is block 2. This represents the acceleration. This is 0. That's what that O is for. So then the acceleration is here. Now immediately, block 2 will move. It moves a little bit, right? And as it's moving, the spring is also compressing. But what does the spring want to do? The spring's the same thing. It's out here just living its best life, and block 1 runs into it, causing all these problems. So the spring goes, wait a second, I don't like being this way. So the spring expands. As it expands, block 2 goes a little bit faster. Okay? And then at time 2, because it's frictionless, after that whole thing takes place, there is no more acceleration. There is no more force being applied. When they break free from each other, the spring cannot apply any more force. And because it's frictionless, block 2 is still moving, but the acceleration is 0. Does that make sense? So what happens is your acceleration increases when the spring is completely compressed. That's when and just as it releases, that's when it's at its max roughly. And then as block 1 moves away, the acceleration decreases, and whatever velocity it's at, it maintains, so the acceleration is 0. There's no change in velocity. Now, what about the center of mass of the acceleration? Well, the center of mass is the center of mass. The block didn't change its shape. If I were to say, what's the center of mass of acceleration of the spring? Well, if the spring changes its shape, well, technically, because it's symmetrical, it'd be in the center. So when we go to do all these calculations, every molecule in that block is moving. Everything in that block has some sort of acceleration. So when we do these calculations, we tend to focus on the center of mass, which helps. But because the block is rigid and it doesn't change, the center of mass never changes. So the acceleration, and I'll show you a video later. We're going to run out of time today where they mark the center of mass on an object and they throw it through the air and it just goes through. It's really kind of a neat thing. So this is the one. The other ones aren't right. This is the only one. Okay? Does that make sense to you guys? All right. So let me stop recording that.